All right, so if two lines are parallel, the slopes have to be exactly the same because slope tells us the steepness, and if they're parallel, the steepness has to be the same. It has to be the same. It's just their y-intercepts may be different. So to demonstrate this with my horrible drawings, and we'll pretend like that's a good drawn y-axis, and that would be a well-drawn x-axis. If we give ourselves two straight lines, which we're pretending that I'm still a good straight line drawer, like this one. So we're going to pretend like those have, of course, the exact same steepness. But of course, you can see this y-intercept is different than this y-intercept, which if they are parallel, they should be. If for some reason the y-intercepts were the same, it would just be a line drawn on top of the other line. And you would have one line twice. Yeah, that sounds good. Which may happen. It may happen. Maybe not in this section, but it may happen. Two lines are perpendicular if their slopes are opposite reciprocal. So when it talks about opposites here, see if I can do this well. We're talking about sines of the slopes. Okay, so that's positive or negative. Okay, so if one is positive, the other one that corresponds with it has to be negative. If one is negative, the other one has to be positive. They have to be opposites. And then reciprocal means that the slope, oh dang it, slope as a fraction. I feel bad typing in front of everyone because it shows how incompetent my typing is, but here we go. The slope as a fraction is, reciprocal just means it's flipped. Okay, so we'll do an example here. Let's say you had a slope of 1/2. Then its reciprocal would be 2/1. Now, of course, you could write that as 2, and so this actually goes both ways. Okay, so if you had started with 2, or you could make it 2/1 and then reciprocate it into 1/2. I'm just showing reciprocals here, I'm not doing anything with the signs. Perpendicularity, just in case you were interested, although I don't think you are, it just tells us that between the two lines, it creates a 90-degree angle. And I will not demonstrate that with my drawings because you can see how I don't want to give you the wrong impression of perpendicularity, not my horrible drawings. So if this was to demonstrate actual perpendicularity on these two, then if the 1/2, let's say that it starts as a positive, then again, we've reciprocated the fraction, but it also has to change the sign from positive to negative. Okay, so here is an equation. This one's in standard form, 2x plus 7y equals -20. It would be great if this was in slope-intercept form because we could find these slopes so easy and so fast. Unfortunately, it is not. So I'm going to change it into slope-intercept form so that I can find the slope. And to do that, that tells us, just again to reiterate, slope-intercept form, y equals mx plus b. And since we're only focused on the slope for this problem, I don't even care about the b. I just want the slope. Now, a common mistake here is that students look at this and they say, well, the slope is the coefficient of x. The coefficient of x is 2, so the slope is 2. No, you need to be careful about that because it is a common enough error that it breaks my heart to take points away. So we need to change it into this actual format, which it is not right now. So let's do on start. I would like to isolate the 7y's there with the principle of equality, so I will. And that I'm going to do that by getting rid of the 2x, which means I'm going to zero it out. So I'm going to subtract 2x. I'll offset the minus 2x here on the right just a little bit. I'm doing that specifically to show that the -21 is not a like term with the -2x, so I cannot combine those two. So the 2x, original 2x, zeroes out. I now have 7y equals, and I'm going to change the order of these because you can. You can change the order of your terms. Just remember, do not combine them. So I now have a -2x and a -21, which would make it negative. The last thing here is we don't want the 7y's. As you can see, we just would like a y. There's a phantom 1 there. If you would like to show it, you can, but you don't have to. So right here, last principle of equality. Maybe I should have given myself more space. I'm gonna get rid of that 7 by making it a 1. So let's go ahead and divide it by itself. But if I do it there, I have to do it everywhere. Notice I'm showing the division differently. I hope that's okay, because I'm doing that because I probably will take the fraction in slope-intercept form. So 7 divided by 7 is 1, and we could show the 1 there, but I'm not, just because it looks prettier this way. And then we have the slope, which is negative 2 over 7. I can't see that could be simplified, though you could check in your calculators, but I'm not going to. So negative 2 over 7. And then the y-intercept, negative 21 divided by 7, which would give us negative 3. So I'm just going to show it as minus 3. I did that y-intercept even though we don't need it for this. So it says a line parallel to the above line would have a slope of, well, we see the slope in that slope-intercept form as negative 2 over 7. It needs to match for a parallel line. For a perpendicular line, we need the slope to be the opposite reciprocal. Okay, so we're going to change the sign and then we're going to flip it, all right? So if I have negative 2/7, which this is not the answer, I'm just showing how to do this here. So the actual slope, we're going to take the opposite. So instead of it being negative, I'm showing the positive sign, which you'd never want to do on the assignment. I'm showing it just so we know that we are actually changing the sign. And then we flip the fraction. So instead of 2 over 7, we now have 7 over 2. And at this point, because that's my answer, I'm going to get rid of that positive sign. This would be the slope there for the perpendicular, and then above the, right there is the parallel line.